All right, today we're going to talk about something huge. We're going to explore the architecture of scientific inquiry. Now, when you hear the word science, don't picture a dusty old textbook. Think of it as this incredibly powerful, elegant process we've designed for understanding the universe. So let's dive in and break down that blueprint. It all starts here, doesn't it? With this one simple question. That feeling you get when you look up at the sky or at a tiny insect and you just have to ask, why? That single word, that little spark of curiosity, is literally the seed from which all scientific knowledge grows. It's the engine that drives everything.
So, what is science, really? At its heart, it's not just a big collection of facts. It's a process, a system. It's the structured way we take that raw curiosity and turn it into reliable, solid knowledge, using the best tools we have: evidence, observation, and good old-fashioned logical reasoning.
But how do you actually get from a question to an answer? Well, you can't just guess. Science gives us a blueprint for that journey, a roadmap for discovery, and we call it the scientific method. And here is that blueprint. It's this beautiful, logical loop. It starts with an observation. You notice something. Let's say your plants in one window seem to be doing way better than the ones in another. Okay, step two, you form a hypothesis, which is really just a fancy way of saying an educated guess. Maybe you think the plants in this window get more sunlight. Then comes the most important part. You experiment. You don't just assume you're right, you test it. You measure the light, you track the growth, you collect the data. And only then, based on that hard evidence, can you draw a conclusion. It's this powerful path from, that's weird, to a verifiable answer. So what's the secret sauce? What makes this whole process so reliable? Well, for one, it's not about anyone's personal opinion. It's built on evidence that can be tested. And here's the big one. For a result to be accepted, other scientists have to be able to repeat your experiment and get the same results. It's this incredible system of peer review and collaboration that acts like a global fact checker, filtering out mistakes and strengthening ideas that hold up. That's how we end up with really solid theories like gravity or evolution. Now, science is obviously vast. I mean, it covers everything from the tiniest particles to the edge of the universe. So to make sense of it all, we have to organize it. You can almost think of it as a map of all human knowledge. And we can break that map down into three huge continents, right? First, you've got the physical sciences. This is your chemistry and physics. It's all about the fundamental rules of the non-living world, matter and energy. Then you have the life sciences, biology. This explores the mind-boggling complexity of living things, from a single cell to a whole rainforest. And finally, you have Earth and space science, which zooms way out to look at our planet, our oceans, and our little place in the cosmos. But, and this is so important, these branches aren't separate islands. They're not totally disconnected. In fact, some of the most exciting breakthroughs happen right where they overlap. You can't understand something as complex as climate change, for example, without chemists, biologists, and astronomers all working together. The real world is messy and interconnected, and so is the best science. Okay, let's bring all of this back down to Earth, because this isn't just some abstract thing for academics. Science is woven into the very fabric of your world, right now. I mean, seriously, just take a second and think about it. The smartphone you're probably holding, that's a miracle of quantum physics and materials science. The medicines that keep us healthy, pure molecular biology. The electricity that's lighting up your room, the food on your plate. Every single bit of our modern life is built on a foundation of scientific discovery. It's like the invisible infrastructure of reality. And this quote really nails it. Science isn't just about understanding the world for the sake of it. It is the #1 engine for changing the world for the better. It's what drives progress, what improves our lives, and what gives us the tools we need to tackle massive global challenges, from fighting diseases to creating clean energy. Which brings us to our final point. And it might be the most important one. Science isn't a destination that we've arrived at. It's a journey that never, ever ends. I love this because it captures the true spirit of science so well. It is not a finished book of facts that you just memorize. It's a continuous journey. The biggest strength of science is its humility, its willingness to be wrong. It's always open to new evidence. It's designed to evolve and improve. It's not a belief system. It's a process for getting closer and closer to the truth. And that's really the ultimate takeaway here. Science isn't just something for scientists. It is a way of thinking, a toolkit for being curious, for looking at evidence, and for thinking critically about the world. And that toolkit helps all of us make better, more informed decisions about our lives, our communities, and our shared future. And that brings us right back to where we started. The entire incredible architecture of science is built on our ability to ask questions. So I'll just leave you with this thought. What are you curious about? What question will you ask